Okay, in this configuration demo video here is going to be about the configuring multi VRF with OSPF version 3. So OSPF version 3 is is what I'm going to use for my OSPF processes here. And in this network diagram, I'm going to have two VRFs, VRF PGE and VRF FPL. So each of these three routers is going to have sub interfaces configured on it. So on router 4, we are going to have the OSPF version 3 process ID 1, area 0. In fact, all of the three routers in this demo is going to be process ID 1, and all three routers are going to be in the area 0 space. So for R4, the loopback 10 is going to be in VRF PGE, and also gig 0/0.10 is going to be in VRF PGE, while the loopback 20 and its G0/0.20 is going to be in the VRF FPL. All right, and then for R5 is going to also have two VRFs, PGE, which consists of loopback 10, and then the gig 0/0.10, which is going to form the OSPF neighbor to R4, and then its gig 0/1.10 sub interface is also going to be in the PG VRF, and that's going to form the OSPF neighbor to R6 in the VRF PGE instance. All right, and then for R5, the sub interfaces is going to form the neighborship to its R4 and its R6 in the VRF FPL. Right, so um, the loopback the loopback 10 is going to be advertised in the VRF PGE, while the loopback 20 is going to be advertised in VRF FPL. And they all have the same loopback um, interface name here, loopback 10 and loopback 20, and then loopback 10 and loopback 20 for all three routers. So basically, these three routers, I'm going to split up the sub interfaces per VRF. All right, R4 is going to neighbor with R5, and then R5 is going to neighbor with R6, while R5 has two neighbors, R4 and R6 in the OSPF version 3 space. So I'm going to configure the IPv6 addresses for these as diagrammed here. So let's go ahead and get started, and then once everything is done, we'll verify the VRFs, and then we'll also verify the OSPF routes per the VRF instance. So let's start with R4. I'm going to go ahead and provide more console space, and I will zoom out to get the IP addresses here for more visibility. Alright, so let's get started here on R4. We say config T. Before we do that, let's do the let's see what we got configured for our IP addresses and interfaces. Exclude unassigned. Oh, no IP addresses for R4. So, and no interfaces for R4. So let's go ahead and configure that. Config T. ITG0/0, and then sub interface. and this shows that the sub interfaces are configured and the loopback is configured, but no IP addresses. That's okay. Let's look at R5. Okay, for R5, the loopback 10 and 20 is configured, and so are the sub interfaces. That looks great. And R6. Okay, R6 has loopbacks and sub interfaces configured. So let's go ahead and configure the IP addresses for R4. For R4, loopback 10 is going to be 4.4/24. We say IP address 4.4.4 255.255.255.0. Oops, no INTLO0. I meant to say INTLO10. Alright, IP address 4.4.4.4 255.255.255.0. Oh, hang on a second. So the thing is, I forgot to mention that if I configure the IP addresses and then I configure the VRFs and then assign the interfaces to that VRF, the IP addresses is going to be blown away. So that doesn't make any sense. Let's go ahead and configure the VRFs first. Let me go ahead and log the console so we can see the neighbors come up. Log console, and then IPv6 unicast routing, turn that on. Alright, let's do that for all of the 3 routers. IPv6 unicast routing, login console. Same thing here, hit option to copy and paste. Alright, let's go back to R4. For R4, we say we got the IPv4 address configured for loopback 10. Let's configure the IPv6 address for loopback 10, which is going to be this guy. So int loopback 10 IPv6. Oh, hang on a second. Sorry, I need to configure the VRF first. VRF definition PGE IP address IPv4 is to enable IPv4 address family IPv4 address family IPv6, and then VRF definition for our second VRF. We need to configure VRF FPL. Alright, and then the address family IPv4 address family IPv6. Alright, so we're going to configure enable IPv4 and v6 for these VRFs. Now let's go ahead and assign the loopback interfaces and this the loopback interfaces to that. Hang on, show IP int brief. Okay, so loopback. Okay, so let's go ahead and assign the interfaces to the VRF and then configure the IP addresses for the interfaces. So int loopback 10 VRF forwarding. This is going to be in the PGE VRF right here. Alright, now we say IP address 4.4.4.4 255.255.255.0. IPv6 address for loopback 10 is going to be 2025 :ABCD: 4:4/64. Alright, so that's loopback 10, and then loopback 20. So we say int loopback 20 VRF forwarding for VRF of FPL right here. That's what we're doing right here. So loopback 20 and gig 0/0.20, they're both going to be on the VRF FPL. IP address is going to be 44.44.44.44 255.255.255.0. IPv6 address is going to be 2025 :ABCD 44, 44, 44 slash 64. All right. Ooh, hang on a second. Show run int lo 20. Okay, that's not right. Let me fix this real quick. That's what I wanted to do. Control A. Fix this real quick. Boom. Okay, that looks good. How about 10? Alright, so 10 is VRF 4 in PGE, 20 is VRF 4 in FPL. Great. Let's go ahead and do the sub interfaces now. For VRF PGE, which is 0/0.10 sub interfaces. PGE IP address is 10.10.45.4. 45 is going to be the network from R4 to R5.4, 255.255.255.0. IPv6 address is going to be 2025 colon ABCD 10 colon network 45 4/64. All right, VRF. Sorry, gig 0/0.20 now. VRF forwarding FPL. All right, and then we say IP address is going to be 10.20.45.4 255.255.255.0. IPv6 address is going to be 2025 ABCD 2045 4 is the host / 64 is the subnet for IPv6. Control A, I forgot the address. All right, so that's G0/20. Show VRF. I got two VRFs configured. One's for FPL and one's for PGE, and there is their assigned interfaces. Show IP int brief. Show int pipe. Include int. That gives me the whole subnet, net mask I mean. So that looks good there. All right. Now let's go ahead and configure on R4. We need to configure our OSPF process, OSPFv3. So we say router OSPFv3 process ID of 1. Okay, because we have multiple VRFs here, we have to configure the VRFs under the OSPFv3. So we say address IPv4 VRF PGE, right? And then we have to define the router ID, which is going to be 4.4.4.4. All right, and then we also need to add IPv6 VRF for PGE. Address family IPv6 VRF PGE. And since we have already defined the router ID for this VRF under IPv4, that should work also for IPv6. All right, so that's that. Show run pipe begin router. If I spell that right, router Okay, so router OSPFv3 has PGE VRF and for V4 and V6, but it doesn't have the VRF for FPL. So I need to configure that because now we have to configure the VRF FPL down here for the loopback 0 and G0/0.20. So configure T router OSPFv3 process ID of 1, address family IPv4 VRF FPL. Okay, and then we say router ID is going to be, I'm going to assign it to be 44 for this VRF. Okay, and then address family IPv6 VRF FPL. Okay, so that's configured for the OSPF routing protocol OSPFv3 for both VRF. Show run pipe begin router. Alright, so we have the PGE and FPL there. Okay, that looks good. So now since the process ID is configured for the address family, let's go back into the loopback interfaces, all the interfaces, and assign those interfaces for that specific VRF OSPF v3. So config T loopback 10, and then we say OSPF v3 process ID of 1, and then we say IPv4, and then this is where we add the area 0. Okay, now we're putting loopback 10 into area 0, right? Loopback 10 into area 0. And we don't need to define the VRF because we already did that in the VRF forwarding statement for that interface. Now we say the same thing for IPv6. Okay, that's done. How about the gig 0/0.10? So let's do that. int g0/0.10 OSPFv3 process ID 1 IPv4 area 0. All right, and then same thing for IPv6. All right, show OSPFv3 1 VRF PGE. What do we get here? Interface brief. All right, so loopback 10 and gig 0/0.10 is assigned to VRF PGE, and I have V4 and V6 configured for that. And since we don't have anything configured for FPL yet, we need to do that. So let's do that. Config T interface loopback 20. Let's put loopback 20 into the FPL VRF. And then I'll say OSPF v3 process ID of 1 OSP IPv4, right, area 0, right, OSPF v3 1 IPv6 area 0. Okay, so loopback 20 has been assigned to area 0 for both its IPv4 and IPv6 addresses. Let's do this for gig 0/0.20. All right. OSPFv3 area process ID 1, IPv4 area 0. Same thing, but for v6. All right. Okay, so FPL's VRF is configured. V4 and V6 is assigned accordingly. So that's pretty much done for router 4. Let's do a show run real quick. Okay, so we defined the VRF definition for FPL for V4 and V6 address family. Same thing for PG&E. And then under the interface, the area has been assigned to the interfaces. So that looks good. Now let's look at the routing process. Router OSP3 version 1. Router ID 4.4. Okay. That looks good. Address family, everything looks good there. Alright, let's move on to R5. Actually, R4 is going to be similar to R6. So let me configure R6. So that way, the OSPF process and VRFs is configured for the two edge routers here, R4 and R6. And then once the final step of configuring R5, we should see the neighbors come up. So let's do R6 first. R6, here we go. VRF definition, same thing. PGE, right? And then under the VRF, we say let's see, do I have IP addresses? Yes, I'll show IP INT brief. Do I have interfaces? Yes, it's already configured. So T VRF definition, PGE, address family IPv4, address family IPv6, VRF definition, FPL, address family IPv4 to enable IPv4, and the address family IPv6 to enable IPv6. Okay, so that's done. Let's go ahead and configure the interfaces, starting with loopback 10 right here. INT loopback 10. Alright. VRF forwarding. Assign this to the VRF of PGE. IP address is going to be 6.6.6.6, 255.255.255.0. And then IPv6 address is going to be 2025:ABCD:6:6, and the host of 6, subnet 64, mask of 64. And then loopback 10 is configured for V4 and V6 of PGE. Let's do gig 0/1.10. Gig 0/1.10. INTG 0/1.10. Oops. INTG 0/1.10. Alright. VRF forwarding PGE. IP address is going to be 10.10.56.6, 255.255.0. IPv6 address 2025:ABCD 10.56.6/64. Okay, so that is for VRF of PGE. Let's configure VRF of FPL for loopback 20 and gig subinterface gig 0/1.20. INT 20 VRF forwarding FPL. IP address is going to be 66.66.66.66.66.255.255.255.0. And then IPv6 address is going to be 2025 colon ABCD colon 66 slash 66 slash 64. Now for the sub interface of gig 0 slash 1.20. IP address 10.20.56.6 255.255.255.0. IPv6 address 2025 ABCD colon 56 6 slash 64. All right. Now, let's verify. Show VRF. Oh, what happened? VRF 40 FPL gig 1 slash 20 is, oh, I didn't configure the VRF for 1-20. Let's go ahead and do that. So now it's probably going to blow away this IP address because I haven't defined I haven't configured VRF forwarding for 1/20 for gig 0 slash 1.20. I'll say VRF forwarding FPL, and there it is. See, no do show VRF. See how it removed the IP address for V4 and V6 because VRF forwarding wasn't is basically if you configure the IP address before you assign the interface to the VRF, and then once you assign the VRF interface, the IPv4 and V6 is going to be removed. So you have to reconfigure, and so I'll do that now. Let's see here. IP address is going to be 10.20.56.6 255.255.255.0. IPv6 address 2025 colon ABCD colon 20 colon 56 colon 6 slash 64. Show okay, so looks good. VRF has been assigned. Okay, let's configure the routing process for OSPF version 3. Router OSPFv3 area. Process ID of 1, and then we'll say address family IPv4 VRF is going to be PGE, and then add the router ID of 6.6.6.6, address family IPv6 VRF PGE, and then also we need to add the VRF FPL under this OSPFv3 process ID. So we'll do address family IPv4. This time it's going to be for the other VRF FPL. Alright, router ID for this FPL VRF instance. It's going to be 66.66.66.66. And also address family IPv6 VRF FPL. Alright, that's good. Show run pipe begin router. OSPFv3 address family IPv4 for PGE has my router ID under the VRF under the IPv4 address family, which will also be good for the IPv6 address family. And that looks good there. So let's now assign the interfaces to the area 0. Loopback 10. OSPFv3 process ID of 1. Right? IPv4, assigning the IPv4 address of this interface to area 0. Assigning the IPv6 address of this interface to area 0. INT G LO 20 OSPFv4 area 0. OSPFv6 area 0 as well. Alright, let's go back and assign gig 10/1.10 to area 0 for its IPv4 and IPv6. Same thing for gig 0/1.20. 1.10 OSPFv3 1 IPv4 area 0. OSPFv3 1 IPv6 area 0. All right. So here is our verification. V4 and V6 is assigned to area 0 for OSPF process ID of 1. Same thing for V6 for the PGE VRF. Let's do the same for the FPL VRF. Alright, so that's pretty much similar. That's good to go. So R6 is configured, R4 is configured for OSPF and all the VRFs. Now we need to do R5. So R5 is going to be a little lengthier configuration. It's going to have 2 VRFs, and then we'll see the neighbors come up once the configuration is good. So here we go. Let's configure the VRF, the top VRF first. Let's configure this top half here. Alright, loopback 10. VRF forwarding. Actually, I need to define VRF. VRF definition. PGE. Alright, address family, IPv4, address family, IPv6, enable those. VRF definition, FPL, address family, IPv4, address family, IPv6. Okay, V4 and V6 is enabled for the 2 VRFs. Let's go ahead and configure the interfaces and assign them to their respective VRF. Loopback 10, VRF forwarding, PGE, IP address 5.5.5.5, IPv6 address 2025 ABCD colon 5:5/64, and then need to do this guy here, gig 0/0.10. VRF forwarding PGE, IP address 10.10.45.5, 255.255.0, IPv6 address 2025 colon ABCD colon 1045 5/64. All right. So that's that. Let's configure the sub interface that connects to R6, also VRF PGE. So let's do that. So that's gig 0/1.10 VRF forwarding PGE, IP address 10.10.56.5 255.255.255.0, IPv6 address 2025 colon ABCD 10.56 5/64. Alright, so that's V4 and V6 configured for the VRF PGE that is going to form a neighbor with R6 once the OSPF routing protocol is configured on R5. So that's the VRF PGE. Let's now focus on the bottom half, VRF FPL on R5. So loopback 20 VRF forwarding FPL, and then IP address 55.55, 55.55, 255.255.255.0, IPv6 address 2025 ABCD 64. Alright, now let's configure the sub interface that connects to R4. So we say intg 0/0.20 VRF forwarding FPL, IP address 10.20.45.5 255.255.255.0, IPv6 address 2025 colon ABCD colon 2045 5/64. Okay, that's good. Let's go ahead now and configure the connection to R6. intg 0/1.20 VRF forwarding FPL, IP address 10.20.56.5 255.0, IPv6 address 2025 ABCD 2056 5/64. Okay, so show VRF. Okay, so the VRFs are configured, interfaces are assigned to it, show IPINT brief. Check out our V6 address to make sure everything's good there. Okay, so that connects to R4, and that connects to R4 also on the FPL VRF. Here's the PGE that connects to R6. Okay, I think we're good. And this is the loopback 20 for VRF FPL. Alright, let's configure the routing OSPFv3 process. Config T router OSPF v3 process ID of 1, right? And then we say address family IPv4 VRF PGE router ID 5.5.5.5 address family IPv6 VRF PGE address family IPv4 VRF FPL router ID VRF router ID is 55.55.55.55 address family IPv6 VRF FPL. Okay, so we are defining the VRFs under this router OSPF process of 1. All right, now let's go ahead and FPL, everything's good there, I believe. Show run pipe begin router. OSPFv3 is configured. Both VRFs have IPv4 and IPv6. Alright, so now let's go ahead and put the let's go ahead and assign the interfaces to the appropriate VRFs, right? So let's go ahead and we're going to into the appropriate area. So loopback 10 first. Loopback 10. OSPF v3 process ID of 1 IPv4 area 0. All right, and the same thing for IPv6. Okay, now let's go ahead and do gig 0/0.10. Okay, once this is configured, the neighbor should come up to R4. OSPv3 1 IPv4 area 0. There it is. VRF PGE to neighbor of 4.4.4 loading to the full state. That's great. Alright, let's go ahead and have V6 come up as a neighbor. There it is. V6 came up. Alright, let's go ahead and turn up the neighbor to VRF of FPL to R4. So we say int g0/0.20 OSPF v3 process ID of 1 IPv4 area 0 OSPF. Neighbor should come up. There it is. Neighbor came up to the VRF FPL, which is right here. Alright, let's go ahead and form the neighbor on the V6 address side. There it is. V6 address side is up as well on the V6 address space. Alright, let's go ahead and form the... Actually, let's go ahead and work on the FPL VRF to R6. First, let me go ahead and just get loopback 20 into the area 0. int loopback 20 OSPF v3 1 IPv4 area 0, and then v6. Neighbors are not going to come up because it's a loopback interfaces, so there's no hello packets sent or received. Okay, so now let's go ahead and do R5 to R6. So first thing, gig 0/0 1.10, int g 0/1.10, OSPFv3 1 area 0, IPv4 area 0. Come on, there it is. Neighbor to router 6 came up for the PGE VRF, which is this guy. Let's go ahead and get the neighbor to come up for VRF FPL. INTG 0/1.20, OSPFv3 1, IPv4 area 0, and V4 is up. I forgot to bring V6 up for the PGE VRF. So let's go ahead and go back to INTG 0/1.10, OSPFv3 1, IPv6 area 0, and we should see the V6 come up, which is great. Now let's do the V6 from R5 to R6, INT G 0/1.20, OSPFv3 1, IPv6 area 0. There it is. All right, everything looks good. Show OSPFv3 VRF PGE interface brief. All right, so we have our backup router, backup designated router to R4 and R5 for VRF PGE. Let's verify that for VRF FPL. Nice. Let's just look at the neighbor. Okay, so here's R5's neighbor to the PGE VRF. So basically, I should see neighbor forming up here to R4, and then neighbor forming up here to R6. And there it is, R4 and R6 for V4 and V6. Let's verify that for FPL. Same thing, FPL. Show IP route VRF PGE OSPF v3. Does that work? Yes, it does work. Great. How about FPL? There it is. All right, so we verified that we have connectivity, formed OSPF version 3 neighborship to V4 and V6 on the sub interfaces between the routers. And so that's how you configure multi VRF with OSPF v3.